How does Amazon help Alexa understand what people mean and not just what they say? Well, I'm talking to someone from the Alexa Smart Home team about that on this episode of Dynamic Developer. I'm your host, Bill Detweiler, and I'm excited to be joined by Evan Wellborn. He's Senior Manager for Applied Science for Alexa Smart Home at Amazon. And we're going to be talking about everything from how the company is using AI and ML to improve Alexa's understanding of what people say. We'll talk a little bit about data privacy, and we'll talk about what the company is seeing around COVID-19 and the types of searches, the types of interactions its customers are having with Alexa. Evan, thanks for joining me.
Yeah, thank you. Thanks for having me.
Before we talk about maybe IoT, we talk about Alexa and kind of what's happening with the COVID pandemic as people are working more from home and as they may have questions that they're asking about uh, Alexa about the pandemic. Let's talk about kind of just your role there at Amazon and what you're doing with Alexa, especially with AI and ML.
Yeah, absolutely. So I lead machine learning for Alexa Smart Home. And what that sort of means generally is that we try to find ways to use machine learning to make smart home more useful and easier to use for everybody that uses smart home. Uh, it's always a challenge because, we've got the early adopters who are tech savvy. They've been using smart home for years, and that's kind of one customer segment. But we've also got the people who are brand new to smart home these days, people who have no background in smart home. They're just unboxing their first light. They may not be that tech savvy. And so a lot of the work is kind of trying to support that end-to-end smart home experience, from unboxing the light to configuring it, setting it up, configuring your smart home groups and spaces, things like that. We and that embodies a number of different features. So there's things like Alexa Hunches, which we launched a couple of years ago and continue to refine. That's where we're kind of identifying anomalies in the home and letting the customer know about them, sort of checking that they've got their back door locked that one time they forget it, every few months. There's Alexa Guard, which is another feature that's about keeping their home safe. We built this algorithm that turns lights on and off in the home to make it look like they're home and they're away from home. Kind of a fun one. And then there's this other feature, we might talk about a little more later, that we're calling it "Did You Mean?" And it's really it's not a named feature necessarily for customers, but it's just something to help customers get through that basic experience of controlling their smart home after they've got it set up. And we're trying there to help Alexa understand what the customer means, not just what they say.
I think that's really important because, the promise of artificial intelligence and machine learning is really, I think, all about prediction. I mean, that's really what you're trying to get to is let's feed this a bunch of data. Let's look for connections. And then how can we do something with that information, right? How can we make a prediction based on the information or a reaction or, take some next action after something happens? And so the "Did You Mean" feature, I think, helps conceptualize that for a lot of, I guess, consumers that maybe thinking about, well, why do I need AI and ML? How is this really going to apply to me in the real world? Has maybe talk a little bit about how that kind of has been part of your thinking as you look at AI and machine learning. Is how can we use this to help consumers, by using, the predictive nature of these algorithms, take some action?
Yeah, it's a great question, and I think "Did You Mean" is a great example feature because it's pretty simple, right? It's addressing problems that come up with the most basic control situation in the home using Alexa. Like the customer may say, "Alexa, turn on the lamp," and what often happens is that there's not an exact match between the word lamp and all the stuff the customer has in their registry. There may be a reading light, or there may be a red bedroom lamp or overhead lights. We've got to figure out what it is that the customer actually means, not just what they said. Uh, and so, the thing that's so interesting about "Did You Mean?" It's such a simple feature. And on the one hand, you can do that basic string match between like lamp and reading lamp. That gets you sort of partway there. But if you think about all the different situations and all the different types of ambiguity that come up in that basic voice control scenario, you really start realizing you need that heavy hammer. You need that machine learning type of algorithm to just make that experience super simple and super natural for the customer. But just to illustrate, like a couple examples, right? So some things I already mentioned, like there's the kind of the synonym scenario where they say lamp and their device is called, light or something like that. Okay, so that's sort of, they're using a synonym that's very common in natural speech. Another thing that can happen because it's a voice assistant, because Alexa is, learning new languages all the time, constantly improving, there still are these speech recognition errors. Maybe somebody's whispering on the other side of the room. We don't get it quite right. Or we there's a transcription error and, we're just a little bit off. And so we've got to figure out, okay, how do we resolve that to one of the customer's devices and just turn it on for them? And then there's, in regards to this sort of international expansion, which is sort of the big move in the last year, we've gone international to many different languages and countries. We've got smart home in Japan, in India, Alexa speaking German, Italian, Japanese, Hindi, Portuguese, all these different languages. We've got to make sure that we can resolve that type of ambiguity in all of those different languages. And then importantly, across languages. That's the new big challenge, is that, in the US, there's a lot of people speaking English and Spanish in the same home, and they may interchange English and Spanish in the same commands. Or even more common in India, people are naming their devices in English, but they refer to them in Hindi. And so we've got to kind of do this code switching across languages to figure out what they mean. And then also, by the way, they're speaking naturally, so they're using synonyms, they're specifying things somewhat ambiguously. We've got to kind of deal with all of that ambiguity to just make this really simple control process work in the best way. And so we're trying to tie together a variety of sort of input features. There's the linguistic information about what they said and what devices they own. But importantly, the thing that's really interesting about this feature and about this smart home space in general is that we're also bringing in all of that context from the physical world. So like behavioral data or sort of environmental context. What room are they in when they're speaking to Alexa? So really, by fusing all of that together, that's how we get to that very simple experience where Alexa just understands what the customer means and makes it really easy for them to just turn on that light or whatever action it is that they want to take.
As someone who's used to writing code, who's used to working on sort of engineering problems, how difficult is dealing with voice compared with all its nuances and complexities that you just laid out compared to other input forms, right? Flipping a switch, touching a button, typing something in and using predictive text that, we've all experienced with web searches. But voice seems to be, as I listen to you explain it, as I talk to other experts, as I talk to people that have been in this field for quite a number of years, a magnitude more difficult to deal with because of all those complexities, because of the different languages, because of the different different contexts that people use when they just speak.
Absolutely. A couple notes about that. So from my perspective, voice absolutely is kind of one of the big frontiers for machine learning. It's super hard problem. It's really exciting. Just in the last couple of years, there have been these big advances in voice, speech recognition, natural language using deep learning, and that's made our lives a lot easier. And so there's some kind of fundamental problems that feel a little bit more solved now, and you can kind of take some of these solutions out of the box and apply them here and there to get you 75% of the way to your solution. But the thing that's really interesting in this smart home space, and I think it's true for most domains when you're dealing with something like a voice assistant, most other application domains that is that you need to kind of fuse that with other types of information. Like that context is really important to figuring out what it is the customer wants when they're giving you these voice commands, right? We need to know where they are. We need to know what time of day it is. We need to know what they usually do in this situation. Things like the angle of the sun are actually important for smart home, predicting like whether they're going to interact with the light or not, that sort of thing. And so it's just a really important, interesting new challenge that we've got this voice capability that's getting better and better, but we've still got to kind of you know apply that type of new voice recognition and NLU technology to our particular application space. And there's that, it gets us maybe 75% of the way there, but that last 25% is about figuring out how do we do this in our situation. What does it mean to speak about smart home? It's a little different than just plain English. A really basic example. If you're just talking about like semantic similarity between what they say and what they mean, if you're in this smart home space, they could say family room and really they mean living room. So there's obvious similarity between family and living when you're talking about a smart home. But if it's just plain English, you're just using an English natural language model, there's not really that much similarity between the words family and living. So all of this kind of gets adapted to the kind of the application space. And I think that's one of the most interesting challenges that my team faces.
As you look at sort of the smart home as a whole, speaking about that context, how difficult is it to get the information that you need to make the predictive decision? The AI and ML is only as good as the algorithms and the people that design it and as the data we feed into it, right? So how do you collect enough information when someone maybe only has one device in their home? It sounds like you get the most data and would be able to predict the best result if you had a variety of devices, say devices that detect ambient light, devices that detect, like you said, temperature, devices that detect. Now you can pack sensors into maybe one device and, a lot of them do that, but it does seem like you almost need multiple sensors, multiple input devices that then kind of allow you to get enough information like you outlaid to help people, to help the system make the right decision at that moment in time. Is that a fair statement? Is that a fair kind of assessment? Or, no, we can really just do it with one kind of thing. We can get data from other sources, whether they're other sources on the internet or, other sources in the area. Talk about that a little bit.
Yeah, absolutely. That's a great question. I think there's kind of a few dimensions to the problem. I mean, one part, it's absolutely true. There's kind of a data sparsity problem, for a lot of customers. They've got, especially brand new customers, they've got one light bulb. It's not the same as if a customer's got this full, decked out house with light bulbs and thermostats, security, they've got everything. Well, that gives us some more information to go on, of course. But right, how do you deal with that data sparsity problem? Well, one of the things that, if we think about the language example, if you just think about English, well, you may not know very much about how I speak English, but other people who speak English. You know how English works, kind of. It's a language, so it varies from person to person and region to region, but there's kind of a general understanding of how it should work. And what we've found, interestingly, about smart home, Internet of Things, is that metaphorically speaking, there's kind of a language to devices and the interaction with devices in the home as well. And that's one of the greatest advantages, we have, is trying to kind of, across many customers, we can understand something about kind of like the language of the home, right? So if someone, for example, they've got two lights, they've got a front porch light and a bedroom lamp. Even just by the names of those devices, we know something about them. Even if they've never used them before, we already know, because we've seen many front porch lights, we've seen many bedroom lamps. We know that probably the front porch light is more likely to just be left on overnight. It's only comes on at dusk, and then it stays on overnight. And the bedroom lamp, well, that's going to be probably on in the evening for a little bit, like half an hour, and then it'll turn off again. It'll be off all night long. So there's kind of there's almost sort of a common sense, or you could think of it kind of like the language of the home. That's something that is incredibly useful, and we see that's true even in the face of this data sparsity problem, that it's really valuable. And of course, as customers get more devices, we learn more about kind of their home setup, and that sort of helps us as well.
I'm someone who, really, I actually have to admit, I have several, smart home devices. I'm in tech. So, I've got Amazon Echo devices. I've got August smart locks. I've got iPad or Apple. Their smart speakers. I've got all kinds of, I've got Philips Hue light bulbs, just throwing out random names of devices that I kind of have around. Not really, don't mean to be promoting any one sort of company, but it's what I'm curious about is as we sort of bring the devices into our house, as we kind of use these devices, I'm a pretty privacy and security conscious kind of person, right? But in order to have value, the system does have to learn some things about me. It's something that in order for me to get the most benefit out of it, it does kind of, like you said, need to know, well, at what time of day do I usually ask it to do these things? And then, oh, it knows, well, Bill likes to do this. So, there's always a concern about, hey, how do we balance that convenience and that sort of the device's ability to help us versus, hey, I don't necessarily want someone else maybe knowing, when I leave my house, because that could open me up to this. Or I just don't want everybody and their cousin to know what products that I buy or what I like, or, what events may be happening in my life that I may be sensitive about. So my question to you is, I guess, not really from a, as someone who is working in this field on a daily basis, as someone who is sort of designing these systems and looking at this, where do you think, and people are already comfortable with giving up a lot of privacy. They have been for decades, with the web, not just with IoT devices. But so, we've already kind of, that Pandora's box has already been opened. But my question is, as the devices are tied more and more into our lives, not just sort of what we do on our screens, but into our everyday lives, where do you see kind of that the concerns of privacy being addressed in the system? Is it more about kind of encryption and ensuring sort of the right kind of data privacy regulations? Is it more towards storing the information on the devices themselves, making the devices, and we've seen some manufacturers work that way, right? Making the devices powerful enough, making the processors powerful enough to do the processing and to store the data on the device, so there doesn't have to be sent to the cloud and back. So my Echo, my smart lock, my HomePod, it may know kind of about me, but the cloud doesn't. So there is a little bit of separation there. Just in general, how do you see that kind of shaping up in the next sort of, few years?
Yeah, it's a good question. As you noted, there's these many different approaches, many different types of sort of technical approaches to dealing with privacy. Some of them have to do with sort of the rigor of encryption. Other things are more architectural, like edge devices and so on. I think sort of a few notes. Like one, if we're talking about sort of overall sort of positioning on privacy and outlook, I'm probably not the best person to speak about that for Amazon in any case. But I think a few things that are definitely true are and also I can't comment on the future roadmap, but we do put customer privacy kind of at the forefront of what we do. Customer trust and control and transparency in data are something that you'll see right now in the Alexa app, and regardless of the architecture, that's sort of how we address privacy going forward. If you think about, I think part of your question was kind of about the architecture. Are we doing this sort of edge computing? Do we see things going more in that direction, or are we uploading things to the cloud? I can't comment too much on that, except to say that there's affordances in each of these approaches, right? You can you sort of push the intelligence to the edge of the device, and you might get a latency benefit as well as some of that privacy benefit. Or you can kind of you can use other types of algorithms and privacy preserving techniques in the cloud that may or may not even work on the device. So there's kind of trade-offs. It's a super interesting challenging space. And for sure, we're working on that as sort of key problem going forward. But again, I can't comment on specific roadmap items.
I completely understand. So let's switch gears a little bit. Let's talk a little bit about kind of COVID-19 and the pandemic and how it's affected people, how it's affected them now that they're working remotely more. Now they may be interacting more with their IoT devices than they had been just 6 months ago. Now that, people are home more, they decide, what, I really want to get some smart devices and IoT devices and add them in. So they may be doing that more. What are some of the ways that you all have seen the pandemic maybe change how people are using the devices? What kind of, either in terms of just the frequency, or actually are they using the devices to learn about COVID-19? What are some of the changes that you've seen over the last 6 months?
Yeah, absolutely. So there's a lot of changes. As you mentioned, people are interacting with devices more often. Some of the places, speaking broadly about Alexa, some of the places we see that most are in the sort of calls between family members. There's I think twice as many calls made with Alexa now as there were at this time last year. There was definitely a spike there. People are using Alexa to stay more informed about COVID-19. And off the top of my head, I don't know the statistics, but people are issuing many queries. They're also issuing queries for things like recipes. People are staying home more often. They're not eating out. So a lot more queries about recipes, streaming media use. All of that is increased for sure. The other thing, if you talk about smart devices and the Internet of Things, is that, kind of as you would expect, people are interacting with their devices more often, right? And we talked about these sort of typical patterns of usage. One of the things we would see, say at this time last year, is a pretty clear pattern of, the 9 to 5 work schedule on weekdays. Like people would interact with devices, mostly in the afternoon when they get home, and again in the morning when they wake up. But there would be this kind of spot in the middle of the day where not much happened. That was kind of like the general trend in our traffic patterns. Whereas weekends looked like a little more balanced. People were at home a little more often, turning off and off lights, using smart plugs, things like that. But now it's remarkable. Worldwide, 90% of our customers, their pattern, that general trend has shifted towards every day looking like weekends used to look, right? So like they're interacting with devices all the time. There's not really as much of a predictable kind of like 9 to 5 pattern in there. And it shows up in our models as well. When we predict things like "Did you mean?" or the hunches feature, we're using those behavioral patterns to try to figure out, should we, did they mean to leave the back door unlocked at this time, or should it be locked? And that's changed remarkably, as people have started working from home. So we've had to, get on top of it and update the models and try to adapt to the changing situation.
I think that's a really excellent point, because one of the criticisms that's leveled at AI and machine learning a lot is that it has trouble dealing with black swan events. That it has this wealth of knowledge, about a specific problem. You fed it all these data sets, but that one black swan event that wasn't in the data set, it obviously couldn't prepare for, because it doesn't understand that it exists. So how did we make, or is it possible to make AI and ML algorithms and systems that can respond to those events? Or does it actually just take humans to still jump in, and, like, I guess you're describing your team did, we saw this event, so we have to adjust our patterns. We have to adjust the algorithms to this new normal.
Yeah, absolutely. It's a hard problem for sure, especially sort of, it's like a critical challenge for artificially intelligent systems, I think, like dealing with these black swan events. There's no training data to support it. And for sure, COVID-19 is giving us one. We see others, throughout the year. Another one, for example, that we saw a couple years ago was the trying to remember, is the McConnor versus Mayweather boxing match. It was like this huge televised event in the summer, and all of a sudden, we had all this traffic for like, televisions and lights and so on. Everything was on that one night, and it was just this like global anomaly, everything all at once. And so, there's other smaller types of events that kind of cause the black swan as well. But I think the solution, interestingly, to me, is that it's partly machine learning and AI, partly building sort of systems that will adapt quickly and can be kind of run collaboratively with a team that's more responsive, perhaps to black swan events. But it's also just in the way you present the feature to customers and the controls that you give them. You have to sort of design the user interaction in a way that is kind of robust to high uncertainty. So for like, even in a very simple way, this did you mean feature is like that, right? We don't automatically take an action just because we have pretty high confidence we are right. We still ask them. We want to make sure that it is in fact what the customer intended. We don't want to do anything to surprise them. And in various ways, whenever we're building some intelligent system for the smart home, we try to sort of consider that in designing the interaction, designing the experience for the customer. Try to sort of understand that in advance there's going to be uncertainty, there's going to be things we're not sure about, so we want to have the customer in the loop sort of with us. It's more of a collaboration than we're going to do this thing automatically and we hope you like it.
So, I guess it's one thing if it's turning off a light bulb, but it is something different if you say you're opening a garage door or closing a garage door, or, taking an action that has more serious consequences than, say, maybe just turning on and off a light. So I guess you do have to use the sort of the old trust but verify method of determining, what the user really intends.
Yeah, absolutely. With the hunches experience, for example, we can lock doors with that. And you don't want to lock the door on somebody if they're just out in their backyard. So that's another one of these examples where we're either going to send them a push notification saying, "Oh, we think maybe your back door should be locked." You've got to go through and do it yourself to lock it, or otherwise, there's this voice experience. We still ask them, "Did you mean to lock? Did you want to lock the back door?" And they've got to say yes and explicitly confirm to take that action. So. Absolutely, that's part of the design.
So I'd love to wrap up by just getting a little bit of your sense about where we're heading in terms of AI and machine learning in respect to smart home devices. Like, what do you see kind of on the horizon? I mean, not specifically about anything you're working on there at Alexa or Amazon's working on. So I don't, you don't have to reveal any kind of roadmap, but just thinking about in general, like as someone who's been in this field for a while now, you kind of start to see kind of trends. What has you excited about the possibilities for AI and machine learning with smart home?
Yeah, I am quite excited. My whole career has been about smart devices and applying machine learning to smart devices. So really excited about where we are now. I think probably the key takeaway and sort of the key point for machine learning and AI applied in the space is that whether we're kind of streamlining that basic experience, making it work for everybody, or whether we're doing something a little more proactive for the customer, like hunches or the guard feature, it's sort of number one that technologies like voice are a great simplifier. We've already seen that with Alexa. It's really what's brought smart home to a much wider audience, and we're trying to leverage that. But even more so, it's the application of machine learning to the physical world, to that context about sort of the behavioral data, the environmental context. That's really what lets us operate intelligently in the physical world. And so it's about kind of fusing more of that contextual information into the experience for the customer that's going to kind of unlock the next wave of smart device experiences and sort of more proactive experiences, whether it's sort of understanding your intentions in the home, or even longer term intentions about goals you want to accomplish in the home beyond turning on and off lights. You want to save money or whatever it is. All of that's going to come back to this kind of a little more physical context. Where's the sun right now? What's the weather like? All of this kind of information is super important in addition to that voice understanding.
Well, Evan, thank you for being here. I really appreciate it again.
Yeah, thank you. It's great to talk to you.
And thank you to all our viewers and listeners for joining us as well. Now, you can listen to more episodes of Dynamic Developer on your favorite podcast platform, or read a transcript and watch a video of this interview at Tech Republic.